what we are going to cover today is immensely important. It's a very beautiful design pattern, and again, something without which some software systems cannot be built, at least at scale. Okay. So you might already know the name of that design pattern. It's called as state design pattern. Now, what is state design pattern? We will delve into it. But what I want you guys to understand is, uh, if you were there in the last class, you might have felt that my focus was always on the point of extensibility, that how we can write a code which can extend to the requirements of future without making so much changes here and there, right? And how is extensibility achieved? What is the most basic feature of any language that promotes extensibility? It is polymorphism, polymorphic type, right? You create an abstract class or you write an interface. Basically, whenever you do that, then you create a polymorphic type, and that allows you to achieve extensibility. So all the design patterns and almost all the design principles also hang around the point of extensibility, which is polymorphic types. Okay, cool. So we will take a very classical example to start the proceedings. So everyone has been to an ATM machine, right? All of you might have interacted as a human with ATM machine. You might have used it to withdraw cash and do stuffs, right? So today what we want to do is we want to write a piece of code that can power a dummy ATM machine. Okay, so yeah, it's a use case. Basically, we have to define use cases for this case study of ATM machine. So rather than me defining it, it'd be much better if it comes from your side. What according to you should be the most basic minimum viable requirements that you would seek out of an ATM software? You can just write in the chat box. Okay, cash withdrawal. Yeah, reading card, checking balance, withdrawing cash. So almost all the comments that I'm seeing so far, they are hanging around the point of withdrawing cash. So there are many other requirements also that an ATM machine serves, like you might just use it for checking your balance, or you might use it for changing your PIN. All those things can be done. These days, ATM machines are also used for doing so many other stuffs, like probably changing your password of net banking and all. But right now we are going to focus on the bare minimal requirements, and the bare minimal requirement for us right now is to be able to withdraw cash. Okay. Now, even if when you think from the perspective of withdrawing cash, there are so many other important requirements that might come to your mind. So can you just think of that? Let's say there is an ATM machine. Have you seen an ATM machine entertaining humans concurrently? Does an ATM machine entertain humans in a sequential manner or in a concurrent manner? It's always sequential. It means that when I am in process of withdrawing my cash, during that time, any other person cannot start his transaction or do anything else using that machine. So a very critical requirement over here is that we should support only one transaction at a time. Okay, when I say we should support only one transaction at a time, what I mean by that is, let's say a person, let's say Aditya goes to ATM machine and he initiates a new transaction. When he initiates a new transaction, let's say he entered his card details have been read, and now let's say he is entering the amount that he wants to withdraw. He's also entering the PIN. In between all of these, somebody else, let's say Shyam, he should not be allowed to start a new transaction, or he should not be allowed to enter his card or do anything. So until unless the previous transaction has ended successfully or has been cancelled gracefully, the other transaction should not be allowed to proceed. So it's a very important requirement. Does that make sense to everyone? Yes or no? And we have to take this requirement seriously. And if you take it seriously, you will see that the way you implement this feature, that will be different from what you would otherwise have gotten. Okay, cool. So I'll just share my screen because I have written down a few things on a doc. So you can see, like I have said, we will focus only on money withdrawal for now. Now, so whenever you have to do a case study, you first focus about the user journey. I mean, how the user interacts with that software. So here, what we want is that user should be able to start a new transaction. So let's say there is an ATM machine, it is idle, nobody is there. Now, when you go inside, you should be able to start a new transaction. Only one transaction should be supported at a time. And then what I have written here in third point, this is incredibly important. So this talks about the different if-else cases that are associated with the usage of that machine. So the first thing is that user should be able to insert his card. So when let's say I'm the first user, and now if I, let's say if I press a button on ATM machine tells me, hey, hello, that means it is ready to take requests. So now I should be able to insert my card. When I insert my card, the next thing the system should do is that it should validate the card details. So it should read the data from the card and send it to the backend server, and then the backend server should process whether these are valid details or not, and the validity response should be sent to the client side, which is to the machine, to the ATM machine. Now, if the card details are found out to be invalid, the card should be ejected. Common sense, right? But if the card details are valid, then what is the next step? Then the next step is that user should be asked to enter his PIN and amount. So now everything is good. The card is good. So now the user can enter his PIN, and after entering his PIN, he can enter the amount. Now, when user has entered his PIN and amount and he has pressed OK, then again, this PIN and amount should go to the backend server. And now backend server should validate these withdrawal details. So by withdrawal details, I mean the combination of PIN and amount, basically. There can be some other data also, but PIN and amount are important. So PIN should be validated, whether it's appropriate PIN or not. And amount should also be validated. The amount should not be larger than the amount that is there in your account. The amount should not be a negative integer. So all those sorts of validations needs to be there, right? And if the validation has failed, if let's say the PIN is invalid or the amount that you have asked for is too much, or you entered a negative amount, you just wanted to play around with the system, whatever it is, then the card should be ejected. Okay. And if everything was valid, then the amount should be dispensed. Once the amount has been dispensed, then the next thing is that you collect the amount, and after you collect the amount, your card should be ejected, and then the job is done. So this is the basic user journey right now. Also, in the fourth point, I have mentioned that cancellation should be allowed at some places, because if a user is interacting with an ATM machine, God knows at any point of time, he might want to just stop, just cancel that transaction. So let's say the user entered his card and the card details were valid. Now the ATM machine is asking him to enter his PIN and amount, but user got a call from his parents that, hey, come back home, we need you here. So the user might want to press a cancel button rather than proceeding ahead with things. So cancellation should be allowed at certain points. And in that case, whenever you cancel, then basically it's like your transaction has terminated gracefully, and now you just go back to your house and some other person can come and initiate the things. What I have shown you right now are not just requirements, but they are concrete requirements. See, in order to build any software, if you want to write some amount of code for it, if you want to do some level of low level design for it, you don't need just requirements, you need concrete requirements. What people usually do is they come up with vague requirements. See, when you come up with vague requirements, you will not be able to think in terms of small components. You will not be able to take any step in terms of implementing any API or writing any function. Okay, so if you are, let's say, sitting for a design review, design meeting inside your organization, or for that matter, let's say you are interviewing for a low-level design interview, and if you feel you are not able to take any step towards implementation, or if you are not able to take any step towards thinking of an API function, anything, then that means that the requirements that you have are not concrete, they are vague. So somebody says that, hey, design an ATM machine that allows us to withdraw cash. This is vague, extremely vague. But now when you read these things, then you get a lot of concreteness in your head that, yeah, these are the cases. And from this, you can probably start writing the code. So this is the first thing that you should do for solving any case study or any low-level design question. Just checking it out. Could you follow me on this? What I meant by concrete requirement and vague requirement, and why is it important to have requirements very concrete instead of vague? Yeah, everyone agrees with that? Okay, great. Cool. Now that we have these requirements with us, so probably we can go ahead and start implementing some classes. So let them be very basic piece of code. We are not planning to write the most scalable piece of code in first go. Let us write a very brute force code for now. So what comes to your mind? You guys tell me. What are some of the classes that comes to your mind? Classes, entities, whatever you want to call them. Account, okay. Somebody says account. Button, card, user. Okay. So let's understand one more thing then. Okay. There are two ways of tackling any design question. The first way is to think in top-bottom manner. The second way is to think in terms of bottom-top manner. Let us understand what I mean by that. Let's pick bottom-top for now. Bottom-top means you have heard we want to design ATM. So now you are thinking in terms of different small entities like, hey, there will be a user will be a class. That class will have different attributes like user ID, username, and so many other things. Similarly, we will have an account will have an attribute account ID and so many other things. Similarly, somebody said session. Yeah, session will also be a class. Button will also be a class, so these are the things that immediately comes to your mind. So you are thinking in terms of different independent components. When you are thinking in terms of different independent components, then the problem that you will face is you will design those components independently very well. But when you have to weave them together, so let's say you have designed user class and account class perfectly well. Now you want to write another class on top of it that probably uses both of them. You might feel that, hey, few things that you did in user and few things that you did in button, they are not appropriate. I mean, they are not written the way they should otherwise have been written. So when you go from bottom to top, when you write the classes which are at the bottom most, and then you create the class on top of it, then you create the class on top of it, you feel like whatever you needed at top, that is not okay with what you have designed at the bottom. It's like you wanted to design your house. You want to design your own house. You want to be your architect. Now you have designed your dining room perfectly well in isolation. You have designed your kitchen perfectly well in isolation. You have designed your washrooms perfectly well in isolation, but you are not able to weave them together to build house in the area that you wanted, right? So when you build things in isolation like that in bottom-top manner, then it is very hard to integrate them and get a fully functioning software. Okay, what is top-bottom? Top-bottom means you start from the point from which user will interact. Okay, so here I see that the most important thing for me right now is ATM itself. So there may be a class called as ATM, and that ATM class will contain different functions. And then those different functions will have some logic to interact with other underlying components. So if you take a top-bottom approach, there whatever you come up with is actually a functionally running software. Okay, there you do not realize that you have written a class, but this class is probably of no use. So what I usually prefer is top-bottom approach, because it allows you to, write a functionally correct thing, and it is more resilient also. Okay, did it make sense? Could you connect with me to understand the difference between bottom-top approach and top-bottom approach? Did that give some clarity? Okay, if that gave, that's great. If not so much, then we are going to just do that. And while I illustrate it, it will be super clear with illustration. Okay, so I'm going to remove it from here for now. So, okay, probably the first thing that comes to my mind is that, hey, we might want to have a very simple class called as ATM. Okay, so do I have a class like that? Might have written somewhere. So I'll just share my screen. Also, in between, if somebody has any question, you can just feel absolutely free to ask that question. Okay, here is my screen. Okay, so let's say we have a simple class called as ATM. Now, what should be the attributes of this class according to you? Let's say there is you are writing a big banking system. Inside that banking system, you have written a class called as ATM. So what are the attributes that you would want this class to have? Just think of it. So ATM ID, location, and also great. I mean, the most important thing you have mentioned. So what Shant has mentioned is ATM ID. See, ATM is a class that you have written. Now you probably will be creating objects of this ATM, right? Now there are thousands of ATMs in this country, and the object that you create for a particular ATM should have a particular ID in order to be distinguished from other object, right? So every ATM should have an ID. I'll call it machine ID. So let's say we have a private final string, and I'm going to call it machine ID. So every ATM has a unique machine ID. And let's inject it inside the constructor. Okay. Now, when you look at ATM, the next thing that comes to our mind is that, hey, this ATM class needs to entertain some functions. So this is an instance variable, but apart from variable, a class also has certain methods. So there'll be different methods. Like I can help you out with some initial method. Let's say some user who interacts with the ATM machine, if the ATM machine is idle, he first presses a button. Let's say there is a start button. He presses that button, as simple as that. So whenever he presses that button, an API is called internally, and that API invokes a method called as init. So init is a very simple method. The responsibility of this method is to start a new transaction and return a unique integer ID for that. So let's say it returns an int. So this is our public int init. Okay. Now I'm not implementing it for now. I'm just returning 0. It's a dummy value that I'm returning. But do you see that the responsibility of this method is whenever it is invoked on this ATM class, it will create a new ID for that transaction and then return that. Okay. Okay, cool. What are the next few methods that comes to your mind? So you have init. Let's say a user has started his transaction, and he got a particular transaction ID for that. Now, the next thing that the user would want to do is he would want to insert his card, right? When a user inserts his card, then what happens? The card details are sent for validation, isn't it? The card details are sent for validation towards the backend system. Okay, there is one thing that I'll tell you. Usually when we talk about low-level design, we generally talk about the piece of code that lies at the backend server. So at this point of time, so many things might be going on in your mind because ATM is a machine and there would be so many things for which are responsible for GUI. So we are not going to focus on that. We are going to basically focus on the server side things. So when you enter something on GUI, it consults your backend systems. by sending the data over there. So this ATM class, you can assume that this is lying at the server side. Okay, and then it has a method like init and probably some other method, let's say validate card details. We probably have a method called as validate card details, and what it does is it takes some card details. So I've already created a class called as card details. You can imagine this card details will contain things like card number and so many other things. And this is a Boolean method for now. Okay. And now again, this will have some piece of logic inside. Okay, cool. Similarly, after validate card details, you will have some other method. So once your card detail has been validated, the next thing you're supposed to do is you're supposed to enter your withdrawal details. When you enter your withdrawal details, those withdrawal details are also sent for validation. So probably you will have a public Boolean method again, and you can call it validate withdrawal details. Okay, and here you can pass in the amount. So let's say amount is in float, and you pass in your PIN. So let's say there is a string PIN, and apart from that, you also pass the transaction ID, which we are talking about. Okay, cool. When your withdrawal details have been validated, of course, it would either be valid or invalid. If it's valid, then the next thing is to dispense cash. So probably we will have a public void method, and we can call it dispense cash. Okay, this would also take some data inside. I'm just skipping that for now. And the responsibility of it is to basically dispense that cash. And then we'll have one more method called as public void eject card. It would also take some data, and the responsibility of it is to eject the card. Anything that comes to my mind is cancel. So public void cancel and take some data, and it would cancel the running transaction. So these are some methods some high level methods that comes to our mind. Okay. Is it clear to everyone, like what is the meaning of all these methods, and why have I declared them here inside the ATM class? By the way, could you connect one thing, that all these methods have been extracted out of the requirements, the concrete requirements that we had mentioned? Could you relate with that? Because when I had mentioned those concrete requirements, I had explicitly said it, that yeah, this is the flow. Like this is when your card details are validated. This is when the cash is dispensed. This is when you can cancel. So once you are clear with those requirements, you can easily list out these functions. And if you're not clear, you won't be able to do that. Okay, cool. Another thing. So if you remember, there was one more very important requirement, and that requirement was that at any point of time, only one transaction should be running. We do not want concurrent transactions. So how do we take care of that? So just think of it in this manner. Let's say there is a certain ATM at a certain society, and it has a machine ID of 0, and somebody invoked init on that machine, and he got a transaction ID for that. Now, the next thing that person did was he inserted his card. So so now validate card details has been invoked. Now think of it in this manner. While this all is happening, if some person somehow uses the endpoint of that server and makes a call to init, what should happen? Should this init produce a new transaction ID and vend that transaction ID to that new person? The answer is no. Why? Because the other person is already in middle of transaction. Do you see the point that I'm trying to make? The point is, when our ATM is already serving a particular customer, and let's say that customer is currently getting his card details validated, during that time, my ATM should not entertain any other customer for anything else. If he somehow calls init via postman tool or via anything, whatever he uses, he should basically be said that, hey, it's not allowed, it's illegal. So it's a requirement. We should implement our functions in a way that it is taken care of. Can you follow me on this? Like what I mean? It's incredibly important, right? So can you suggest me some very basic ways to take care of this? What do you think should be done? Can we set flag at the beginning of transaction? Okay. Mhm. Only one object of class. Okay. Probably you're pointing to a design pattern called as singleton pattern. If you have only one object of a class, then also this problem can happen, isn't it? Because even in that case, using that only one object, somebody can invoke init. This problem can be taken care of by only, having some sort of logic inside here that does not allow that to happen. By using locks and all. Okay. So when you use lock, you basically take lock on a critical section of your code and you exit that critical section when your job is done. Now here, do you see that the situation is very, very different? I mean, the API calls to init, the API call to validate card details, the API call to this, the API call to that will be coming at different point of time from the client side. It's not like you call init once and then you hold a lock and then your job is done. Also, more important than that is that there can be different servers on which different calls are coming. If you have multiple bank servers, and let's say a client has initiated a transaction, then probably init happened on one server. But now when he's trying to get his card details validated, that is happening on some other server. So just by acquiring some sort of lock, things are not going to be taken care of. Why? Because the operations are happening in a distributed manner across different machines. They're not happening in one go at one machine. Is it making some sense? Do you get a hang of things that why making things synchronized or thread safety and all is not going to work? That's not going to work. The problem is worse than that. Okay. So like, okay, like when I probably come up with the solution, I'll talk more about it and then it'll be much more clearer. But for now, let me tell you that making things synchronized is not going to help. Acquiring locks and all will not help you out in this case. We'll have to do something else. Initialize one state of a class and don't allow init when this state is set. Yes, that is one way in which you can think. Guys, think of it in this manner. Here, what is the situation? The situation is that at any point of time, our ATM machine is in a certain state. Our ATM machine is in a certain state. So we can say that initially our ATM machine, let's say it is in ready state. When it is in ready state, during that time, what are the operations that it should support? During that time, it should only support init. It should not support any other operation. Okay. So now let's say somebody initiated a transaction. Somebody has just started a transaction. In that case, what happens? In that case, we can imagine that now our machine has moved from one state to another state. So it was in ready state and now it has moved to some other state. Let's call that as card reading state. You might have seen so many softwares, you might have encountered so many machines where you press a button and then that machine goes to some other state. You press another button, it comes back to some other state. So for systems like this, which can be in multiple states, we first need to come up with some sort of state diagram. State diagram is not a hi-fi thing. It is a very, I would say, common sense based thing. But because I have a state diagram handy with me, so I'll show you. Everyone can see that there is a state diagram. Anyone who can't see it. Okay. So just look at it for some time. Just look at that state diagram for some time. Okay. So if you can see it, can you find out one thing that there are different states inside it? Like there is a ready state, and then there is a card reading state. There is card ejecting state. There is withdrawal details reading state, and then there is a cash dispensing state. So overall, there are 1, 2, 3, 4, 5 different states. Can everyone see 5 different states listed down there? Yeah. Okay. So I'll just be writing few things. So if you're looking there, the machine is initially at ready state. When it is at ready state, the operation that is allowed is init. Okay. When you init, what is the next state that you go on to? The machine goes on to the next state of card details reading state. Okay. Now, when you are at card details reading state, at this point of time, if you want, then you can cancel the transaction. If you cancel the transaction, which state should you come back to? You should come back to the ready state. So I can say that here, if somebody cancels, then he goes back to the ready state, right? Okay. Now, when you are at card details reading state, the next operation that you can perform is to read your card details or validate the card details. Now you can see that at this particular state, if the operation performed is read card details, then this operation can either return a true or false. If it returns false, it means that the card details are invalid. Now, if the card details are invalid, what will happen? That now you will move on to the card ejecting state, right? Where the card is to be ejected. And if the details are valid, then you will move on to some other state, which is withdrawal details reading state, right? And when you move on to withdrawal details reading state, again, you have multiple options. In withdrawal detail reading state, you mention your withdrawal details, you mention your PIN, your amount, and then depending upon whether the response is true or false, you move on to some other state. So what we can basically notice that there are different states and there are different transitions that are associated with those states. So let's say there is a state S, and at that state S, different transitions can happen. Transition are like these functions. So init is a transition, cancel is a transition. Every method that I have written can be thought of as nothing but a transition. And whenever a transition happens, your system moves from one state to another state. That's all that happens. So basically, we need to be wary of what is the state of our system. If we know the state of our system, then only we can figure out whether a particular transition is allowed or it is not allowed. Yeah, is that making sense? Yeah. So one thing that probably I might want to introduce in this case is notion of state. Okay. So if I go back to the code that I had written, I can say that, hey, introduce one more thing and call it as private ATM state. Okay. So there is something called as a state. And let's say the first thing that we do is if you take a look, what I have made this state for now is it's an enum. It's a simple enum. So you can see that an ATM can either be in ready state or card reading or withdrawal details reading or this or that, right? We are maintaining state of transaction or user. We are maintaining state of the machine, which state that machine is in. And because a machine can only support one transaction at a time, so basically there is no need to, as long as you are maintaining state for a machine, there is no need to maintain state for transaction, because at a time it only takes care of one transaction. Okay, cool. Now that we have this state, we can say that, okay, when things have begun, we can say that this dot state can be initialized to ATM state dot ready to start. Now, let's say you want to implement init method. How do you think this implementation should look like? If we find out that this dot state dot equals ATM state dot card reading. Let's say this is the scenario. Now you guys suggest what should happen at this point of time. If you see that init has been invoked, and at that point, the machine is in card reading state, what would you want to do? What would it mean? It would mean that somebody called in it on my ATM, despite the fact that currently my ATM is serving some other customer and it is in card reading state. So if it has happened, it's an error scenario and it's my responsibility to throw an exception. Is it making sense that why this is a scenario where we should be throwing an exception? So we should say that here we can throw new runtime exception with a proper message. So we can say that you can give your message can't init. Currently we are in card reading state. Currently we are in card reading state. Okay, cool. So similarly, let's say if you find out that it's in some other state, the init has been invoked and you figure out that your system is in some other state. Let's say that is cash dispensing state. Again, in that case, you might want to do something else. You might want to throw an exception. This time probably with some other message. You would say that currently we are in cash dispensing state. Okay. What I want to illustrate from here is, do you guys see that there will be so many if-else conditions that will be coming up? That too not in just init method, but in all the methods. Do you see that? Yes or no? Yeah. Why? Because the behavior of a method, I'm just writing it here. The behavior of a method is dependent upon what? Tell me. Init behaved in a certain way here and in a different way here because of state. So behavior of a method is dependent upon the current state. Very good. Now it's very important to realize it. Such sort of software systems where a method or an API or a function, whatever you call it, behaves in one way when it's in state 1 and behaves in some other way when it is in state 2, they are called as state-based systems. And I'm pretty sure you might have encountered a lot of systems in your day-to-day life like that. Okay, so have you used a TV remote? TV remote contains a power button. Okay, now if you hit a power button, if you press the power button and your TV is off, what happens? It runs the logic to turn the TV on. But if you press that button while the TV is on, then it runs the logic to turn the TV off. Do you see what I'm saying? Can you connect to my point on this? Yeah. Can you quote some other example? Just think. I'm sure you'll come up with a lot of examples that you're using in day-to-day life where certain system behaves differently for different instances. Think about buttons only. Like here, I thought in terms of that power button of remote. Can you think of some other button? Just look at your keyboard. Right now, you must be using your computer. So look at your keyboard and see a button. Mute. Very good. So on your keyboard, there is a mute button, right? Now, if you hit that mute button, and if you're not on mute, you become mute. And if you are mute and then you're hitting, then basically it unmutes. So basically, the behavior of a method depends upon what state you are currently in. That makes sense to everyone, right? You know, the same sort of thing will happen here at a lot many different places. Just think of any other function. Like here, validate card details. When you're talking about validate card details, when should it run? When should the validation be allowed? Validation should be allowed only if the current state is what? Card reading state, isn't it? If you have moved from ready state to card reading state, then only the validation of card should be allowed. Just look at that state diagram that that I had pointed you to. So basically the point over here is that in such sort of systems, we will be encountering a lot of functions where requirement will be something like this. Yeah, so you will see that you have a function that you have to implement. Let's say that function is t. And now you see that if the current state is S1, we want to do one thing. If the current state is S3, we want to do something. If the current state is S5, we want to throw error. So, all such sorts of scenarios, whenever these kind of scenarios comes, then basically it's the point of a state-based system. And now how to deal with these state-based systems. So right now, the state-based system that I took here as an example was very trivial, was very simple. It was an ATM machine which just had 5 states and had some transitions. But you may have a very complicated state-based systems where there are, let's say, 20, 25 different states that the machine can be in. And from each state, there are different transitions that are coming out. Corresponding to one transition, you are moving to some other state. Corresponding to some other transition, you are moving out to some other state, right? So all these things. See, if you look at your current state diagram only, then you will see that when your cancel method is called, let's say somebody calls cancel method. Can you see the state diagram, everyone? Just head back to that state diagram. When cancel method is called, what is your next state? If I ask you this question, I call the cancel method. What is my next state? Now your answer will be that, hey, it depends upon what was your previous state, isn't it? So if your current state was withdrawal details reading, and now cancel has been invoked, then you move on to card ejecting state. But if your current state is card reading, and then you performed a cancel, then you go back to the ready state. So basically, behavior of a method is dependent upon the current state. And also, what should be your next state, that totally depends upon what is your current state. Yeah. So just think of it in this manner. Let's say there is a state A, and if transition T happens at A, you go to B. And if the same transition T happens at state Y, you go to Z. Right? So all these things can happen. There are so many if-else conditions that are going to come. And of course, we don't want to live with those if-else conditions. So what do you think we should do? What is the basic way to get rid of it? So you can take some inspiration from strategy pattern itself and then suggest some solutions to it. It's okay, even if those solutions you feel they could be wrong or anything, that's totally okay. What did we learn in strategy pattern? Let's first recall that. The part of the code which is changing, we will pluck it out and we will make it as a polymorphic type, isn't it? Now, what is it on which the behavior of different methods are dependent? State. So what if we pluck this state thing out and make it as a polymorphic type? Would that be a better choice? So let's just take a look. So what I have decided to do is I'll create an interface called as state. Okay, now it is a polymorphic type. Now inside this interface, there are these methods: init, read card, cancel transaction, all these methods are there. Okay, all these methods which were there inside ATM, for which you had written so many if-else conditions, they are now inside this state. Okay, now there are different implementations of this state. So let's say you can think of an interface as an abstract class. Okay, now let's say I want to write a concrete class called as ready state. So now you can see that this is my ready state that implements that state. So it will have its own version of init. So this is how it implements init method. It says that I'll first, I'll talk to database, I'll fetch a transaction ID. If I am not able to fetch it, if it is 0, then I'll throw runtime exception. Otherwise, I'll return it. Okay, what this line is doing, I'll talk about that later, but forget about it for now. So you can see that init has a specific implementation for ready state. Okay. When you are in cash dispensing state, in that case, init will be made to throw an exception. When you are in card reading state, there also init will be made to throw an exception. When you are in any other state, let's say card ejecting state, there also init will be made to throw an exception. Right? Now you look at any other method. Let's say you have a method called as read card. So read card is implemented in a certain way for card reading state. but it might be implemented in some other different ways for other states. So what I have done is that now there is a super type called as state. And now if you look at my ATM class, this ATM class depends on state, which is a polymorphic type. Now, if init has been invoked, all that we do is we call this dot state dot init. Now think of it in this manner. If the current state was ready state, in that case, the init method would have been invoked for ready state. But if let's say the current state was cash dispensing state, in that case, init would have been invoked for this. An illegal argument exception would have been thrown. The beautiful thing that has happened is that all those nasty if-else checks that we previously had inside init, inside all the other methods, now they are no longer there. Why? Because they reside in their respective concrete classes, which are coded against a common super type, against a common interface. So this is how I have made my ATM oblivious of different kind of states. So now this ATM does not have to get into the nonsense of what current state is and how to behave for that state. Do you see this point? How many of you see this point? Just type in yes or no. Do you find it pretty much related to strategy pattern only? The answer is yes. It is pretty much related to strategy pattern only, but it is a special case of strategy pattern where a software has multiple states and there are multiple transitions. Do you see my point? So state pattern is a special kind of strategy pattern only, but it's a special case of that, where there are different states inside your system, as simple as that. Okay, one more thing. It's very important for us to move our ATM from one state to another state whenever a transition occurs. Because if the current state is, let's say, X, and the transition that happened is T, then that transition should make sure that now the ATM has been moved from state X to some other state, let's say state Y. You know, for that reason, I have not made my state as final. Because if I make my state as final, I'll not be able to do so. Machine ID is final. Machine ID is going to be same throughout, but state is not final. Why? Because of this reason. Do you get that? Why the state is not final? It's not just a random choice to make it non-final, but it has to be non-final because of that reason. Now, one more thing. Tell me one thing. Let's say you wanted to perform init and you performed this init. Now, the next thing is to move to some other state. The logic to move to the next state, should that exist inside this ATM class only, or should that exist inside the concrete state? Where should it exist? Just think and say. So I'll tell you the question that I basically mean. So say you performed an init and you got an ID. And I captured this ID here. And later I'll return that ID. But before returning that ID, it's my responsibility to move myself, to move the ATM to another state. So probably I would want to do something like this, no, this dot state. If you look at your state diagram, then whenever init is called, we move from ready state to the next state. And what is that next state? It is, I think, card reading state. So this should now be made equal to new of card reading state. Something like this should happen. So my question to you is, this transition from one state to the other, should it happen inside this init, or should it happen inside the init which is implemented inside that particular state? Where should it happen? I mean, you can just say, should it happen at the first place or the second place? Inside the concrete class. Do you see? It must happen inside the concrete class. What is the reason behind that? Tell me. There are multiple reasons behind that. I'll tell you all those reasons one by one. Do you remember in the last class, we had talked about a principle, a design principle that says that your core class should depend upon abstract type. It should not depend upon concrete types. How many of you remember that principle? This state over here is an abstract class, isn't it? Yeah, dependency inversion principle. State is an abstract class. It is not a concrete class. Now, the moment you are writing this kind of code, it means that ATM needs to know about these classes. It needs to know about that, hey, there is a class called as card reading state. There is a class called as card ejecting state. So that is first reason. If you do anything like this, then you're violating dependency inversion principle. So we should not do that. Another reason is that whenever init has been invoked, whenever a transition happens, then the next state depends upon the previous state, right? Let's say a transition T happens, and if it happens at state X, you go to Y, but if it happens at state P, you go to Q. So you might want to put that logic over here that, hey, if I'm just writing pseudocode, hey, if current state is P, then write a code to move to Q. But else if the current state is something else, then write a code to move to something else. This is even worse, right? So this is something that we don't need. Because of that, the logic to hop on to the next state has been written inside the respective classes. So now you can see inside ready state, we have a piece of code that knows that, hey, if the current state is ready and init has been invoked, then the next state should be card reading state. That is the reason this logic has been kept over here. Is it making sense to everyone? Yes or no? It's an incredibly important point to understand about state pattern, that states are the owners of change, that what is the next state that we need to hop to, not the Uber class, not the upper class. Not sure if it's clear to everyone. You guys can just respond if that made any sense, because there is something that I need to talk quite related to it. Yeah, makes sense to all? Okay. Great. Now that we know this thing, do you believe that these state classes, these concrete state classes, need to have a dependency on ATM? Because if you want states to alter the state of ATM, let's say if you want this ready state class to change the state of ATM, that means this ATM should be some instance variable of that, right? That is the reason I have, inside every state, we are passing that ATM object. Because until unless those state have a reference to that ATM, they won't be able to perform the change. You see, there is a read card method. So whenever we are reading the card in card reading state, and if the result is valid, then we change the state to withdrawal details reading. And if the result is invalid, then we change the state back to ready state, right? This is something that we do. So basically, the point is that all these state classes, independent state classes, should have a reference to the actual ATM class also. If they do not have that, they will not be able to modify their states. Does this point make sense to all? That why all of them need to have a reference to that? And inside this ATM class, you can see that there is that method. There is a method called as change state. And this change state is being invoked internally by all those state classes. Okay, the point is that if you want to change the state of ATM from a particular concrete class, it means that the ATM object should be accessible to that class, right? Then only that class can do something like ATM.change state, right? So all the concrete state classes that I have written, all of them have reference to the actual ATM. Okay, basically inside their constructor, the ATM has been sent, right? Inside all the different states. Because if they do not know about the ATM class, they won't be able to change the state associated with it. How is this ATM object common to all state classes, not individual ATM object? So it can very easily be ensured. So let's say you have your ATM class. Now, whenever you initialize your, this is your final ATM class. Whenever you initialize your ATM class, you initialize with it with a state, with a machine ID. And then, although I have not talked about the database part, but in order to persist data, you persist data inside a database. So I somehow first read the state from database, and then I initialize the state to this. And now I make sure that whenever any method is invoked, then that method basically, consults a state class, and that state class has a reference to the same ATM basically, because you can see here also, like whenever you initialize this ATM class, what we do is that we initialize it with the same ATM, this, right? So this means we are pointing to the same ATM, the current object, whatever is the current object. Okay. Now there is one very, so this was about the state pattern. So if I have to summarize it, what I would say is, if you are designing any system and you feel that there are multiple states which that system can hold, and then there are different transitions that happens across different states. In that case, state design pattern is the pattern to go with, because if you don't go with that, all that you will end up with will be so many if-else conditions. If you want to get rid of all those if-else conditions, you have to abstract out the state entity. You have to make it a polymorphic type, and then you have to make this top thing depend only on the polymorphic state. That's it. There is one con of this approach. I'll tell you what that con is. All the states have to know about one another. So what I mean by that is, let's talk about ready state. Ready state needs to know that, hey, there is a state called as card reading state. Then only it can change the ATM to that state. Similarly, card reading state needs to know that, hey, there is a state called as withdrawal detail reading state. There is a state called as ready state. So the thing is that all the children of state, state is a super type and all these concrete states are the children, all these children need to know about one another, right? That is the only con of it, right? Because it kind of violates the dependency inversion principle. The dependency inversion principle says that if you are writing a class, it should not depend on too many concrete classes. It should depend only on the abstract classes. So you have taken care of dependency inversion principle for your most important and high level class, but all those children of state, they still have to know about one another. Do you get this point? That why this is a con and why we have to live with this con in case of a state design pattern? Yes or no? Okay, cool. So this was some idea about state design pattern. Now, in order to, because I think I've talked about a lot of things. So when you go back, then the homework that you should take for yourself is to watch that video. So there is that, the link that I have sent you, in that there are small parts of whatever I have talked right now, and that is much more lucid also. So just go through those, and then your understanding will be much more sublime in terms of what is state pattern and how it is actually implemented. Just before we leave, I'll ask you one question. Can you think of some very standard systems where state design pattern would be an important requirement? Or can you recall some classical interview questions, LLD interview questions that people usually ask where this is a go-to pattern? Okay, so how many of you have used a vending machine? Did you ever use a vending machine anywhere? Maybe in your office or on airport, anywhere. Did you use it? Do you think that's a classical case? That's a classical case of state pattern. Vending machine, at a time, it entertains only one customer, isn't it? I mean, when you are trying to withdraw a Coke from that, then there are different things that you do. You first choose an item. When you choose an item, it moves to some other state. Then you make a payment, it moves to some other state. Then it dispenses the item, and then it dispenses the change. So it completes one transaction, then only moves on to another transaction. So it's like vending machine is also in, different states, right? And whenever you are at a particular state, there are only certain methods that you can perform from there. If you perform some other methods, you need to throw exception. Also, at any point of time, you can cancel. And whenever you cancel, you go back to some other state, depending upon what your current state is. So vending machine is also a very, very classical example of a state design pattern. Does it make sense? Could you relate to why vending machine falls under the category of state design pattern? Do you agree with it? Yes or no? What do you say? Yeah. Any other example? Elevator, even elevator. Yeah, just tell me. See, your elevator, just think about it. It's a good food for thought. Like when you perform any action on the elevator, let's say you press a certain button, how it behaves, it depends upon the current state. Let's say an elevator is currently moving up. It's moving up, 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 up. It's in motion. It's not at rest, it's in motion. During that time, if you press the button to open the door, what happens? Does the door open? I'm pretty sure if it opens, then you'll be in trouble, right? So during that time, the software throws an exception. The software says that, hey, currently we are in motion, you cannot open. But if you hit that open button when the elevator is at rest on a floor, then it'll open up. So that behavior is dependent on, what is the current state of the machine. Uber, we can only book one cab at a time. Yeah, but I can think of even better example than that. How many of you have placed an order on Amazon? Now, when you place an order on Amazon, or let's say you place an order on Swiggy, you are allowed to cancel that order only at certain point of time. So if your order is not out for delivery from Amazon, then probably you can cancel. But if it is with delivery guy, if he is, let's say, already bringing it, they might not want you to cancel it because they have already invested a lot on logistics and they might want to incur some charges and other sorts of things, right? The same thing is with the Swiggy food also. I mean, if you want to change your food items, if you want to give some, let's say, cooking instructions, or if you want to cancel, then they are allowed only when your order is at a certain state. So let's say if your order is out for delivery on Swiggy, during that time, they won't allow you to probably cancel it. Now they might, but there can be a very standard requirement where if I am doing it, I might not want my customers to cancel during that time. Yeah, if an order has been placed and the cooking has not started, during that time, I might want him to be able to perform cancel operation, but not at any random state. So basically, whenever you are dealing with a case study like that, where you feel like when you are performing an action, then that action, the way it is implemented, it's totally dependent upon the current state. Then that is a classical case of state design pattern. Yeah, you can think of many more examples, but could you overall get a high level gist of what this pattern is all about? You will learn how to implement it when you watch those videos. Don't worry about the implementation nuances, but could you get the high level stuffs associated with state pattern? Yeah, if you got that much, then that's a good job. That's a job good done. Well done. So now the next thing you should do is you should watch the videos which are there on your dashboard, and you will get a hang of complete implementation and all those things. And once implement it on your own for any random system, okay, certain video games are great example of state pattern. Sample code and all, they are there on those videos. I mean, I don't have the PDF or files of that right now, but they are listed on that video. So you can try writing. If you face issues, you can ask us. We'll help you out with that. Certain video games are also great example of state design pattern. I mean, when you are playing a video game and you hit a button, then once you hit that button, the behavior that you see is dependent upon the state which the game is in right now. Do you recall any game like that, where you used to hit a button and what used to happen depended upon where the ball is or where the bat is? Okay, think of it. Just think of it. You will be able to come up with multiple such examples. Okay. Okay, explore it more, write some code, and then I think your understanding will only solidify with time about it. It's a beautiful design pattern.